So we'd like to plot a function of the form y equals f of x. All right? And the way we're going to do that is we're going to adaptively sample this function over the domain that we're plotting. So suppose we have, this is our screen here, which has width w. And here is x1 and here is x2. So as x goes from x1 to x2, we traverse the plotting region. Now we want to plot this, so the naive approach, the simplest case, is to just sample it a bunch of times and then draw a line connecting all of those samples. So we might sample it, for example, like if width is in pixels, then maybe we sample it 0.5 times w times. That way, the distance between samples is 2 pixels. And then once we have them, suppose it's the sine wave, and we draw our graph. However, there's a couple cases where this won't help, or this won't work very well. So one case is when the graph has very sharp turns. So for example, suppose we have a very high frequency sine graph that goes very high frequency here. Then it's conceivable that the samples, for reasons that are quite similar to like the Nyquist frequency in signal processing, the samples will give a graph that looks like this or like this. Something that's not correct, right? Because what's happening is you're sampling these, and if you're not, the samples aren't really fine enough to observe the small scale changes, the small gradations in this function. So what we're going to do is adaptively sample. So the way that this works is, suppose we have 3 samples here, right? We measure the angle between the samples, like so. And if this angle is greater than some threshold, or more likely that it's complementary angle, or complementary or supplementary, whatever one, 180 minus angle, if that angle is smaller than some threshold, epsilon, then we subdivide this further. So we sample these 3, now we sample here and sample here in the middle. And then we repeat. So if this angle is, if it's great enough, if it's small enough, if it's not sufficiently close to 180 degrees, then again we break it down and sample. And eventually, either we'll get to like the recursion limit, which will maybe be something like 20, or we'll say, hey, like if you are already having like 50,000 points, that's just enough, let's just stop, because otherwise the function would be too many points. And that kind of thing would happen if you have like a very high frequency sine graph and you're zoomed out very far. So in that case, we'd probably want to do a breadth first rather than depth first scenario, because in a breadth first case, then the graph is roughly done, but done okay for the entire region. Whereas if it was depth first and we reached that maximum of 50,000, then only the first part of the graph would be fully rendered. The rest of it would not be. So there's another important case that Grapheme needs to deal with, Desmos, which is maybe a good example of this is like in the function inverse hyperbolic tangent of x. Now what this function looks like probably also applies to inverse of tangent, but if we graph this function, it looks like this. So it has, oops, that's terrible. So it has 2 vertical asymptotes at x equals plus or minus 1. Now, the issue is that if we just naively sample, then what will happen in the actual graph is it won't go all the way to the end of the vertical asymptote. So it might look like this where it's cut off here, when it should go all the way down here, right? So the way that's going to work is if we ever have a period of sampling with the following pattern, so not a number, then sample, and then sample, or sample, sample, not a number, then we'll choose the number here in the middle and again sample. And then we'll keep doing that and a bit down to some recursion limit once again, and that will basically that will kind of tell us how close we get to this not a number, like how close we can get, and the full range of values that function can take as we approach this sort of asymptote or critical point, whatever it is. So overall, that will be the grapheme plotting algorithm. There will probably be a couple of appearances of interval arithmetic in here, but this is the basic idea at least.